Dear students, Assalamu alaikum. I am Abdurrahman Abbasi, your instructor of decision theory and analysis. In previous lecture, we discussed about the chi-square test of independence if the data is more than one variable or two categorical variables or more. So the test of independence will be used. So we discussed about the test of independence, how the test of independence can be used through analysis of cross tabulation. So we tried to resolve an example regarding the meals served to the students and class standing. We have two categorical variables and we testify the hypothesis regarding these two variables to check the relationship between these two variables. Either the null hypothesis will be accepted or alternative hypothesis will be accepted. So today we will try to resolve this kind of issue and make the decision regarding the acceptance or rejection of hypothesis in chi-square test of independence for two categorical variables. So let's start the lecture. So in previous lecture we have the example regarding meal plan selected for 200 students in this below table. So we have fresh, soft, juniors and senior candidates students for testing the class standing and number of meals per week to check the relationship between these two categorical variables. So we formulate the hypothesis. One is a null hypothesis and other one is an alternative hypothesis. Null hypothesis says that the meal plan and class standing are independent. They have no any relationship or association between these two. So whereas alternative hypothesis says that meal plan and class standing are dependent and there is some kind of relationship in between these two categorical variables. So to resolve this issue, we have the data of 200 students regarding the meal plans. Now these are the observed values. These are the basically observed values. These are observed values which are observed from these 200 students regarding the class standing and number of meal plan. So now we have need to explore the expected values or expected cell frequencies. So for this concern, we need to try or find out the expected values or expected cell frequencies. Expected cell frequencies. Okay, fine. So as we have obtained the data of the 200 students regarding their meal plan and class standing, this is the overall data table, and with the same type we have to construct a table for expected cell frequencies. So with the same type, class standing, is a one categorical variable. And number of meals per week, second categorical variable. Number of meals, per week. Per week. And total. So number of weeks, 20 weeks. (10-week), none, and total. Now you can check, we have to construct same type of table like this observed frequencies. So we have to construct now the expected cell frequencies from this observed frequency table. Now we have the fresh students. And total. Fresh students, SOF, juniors, senior. Senior. This is a table. Now we will put the values from this table, as we already know regarding the formula of F observed is equal to number of row total multiply column total divided by n. So this is basically the cross tabulation formula. Observed frequency is equal to row total multiply column total divided by n. So first we have to cross the row total and column total and then divided by n. N means number of total cases. Number of total cases. So it means, so we can look, we can see at this observed table that we have total 70. Total 70 rows in fresh, 60 rows in SOF, 30 rows in junior and 40 rows in senior. The subtotal is 200. Whereas in column total, for 20 weeks 70, for 10 weeks 88, for none 42, total 200. Okay, so now as per formula, the row total multiply column total divided by n. So here from these observed values we can see the row total for fresh candidates is 24, 32, 14 equal to 70. So row total is 70 and the column total for these 20 weeks is 70. So we can apply these values over here. Row total is 70. Okay, so 70 multiply column total for fresh column total for fresh is 70 divided by n. N is total students. Total students are 200. Total students are 200. So is equal to, we can check, 70 multiply 70 divided by 200 is equal to 24.5 is equal to 24.5. So fresh candidate for 20 weeks is 22 in observed values, whereas we obtained from the observed values 24.5 for expected cell frequencies for 20 weeks. 24.5. Okay, now with the same method, with the same formula, we have again apply for fresh students 32, 70 multiply 88, 70 multiply 88 divided by 200 for this fresh students for 10 weeks. We have the row total is 70 and column total for 10 weeks is 88. So this we applied here 70 multiply 88 divided by 200, which is equal to 70 multiply 88 divided by 200, 30.8. So we have observed value 32 in fresh for 10 weeks. Now we obtained expected value. We obtained expected value for 10 weeks is 30.8. This is 30.8. Okay. So with the same method, from expected value for the none, 14 is the none value for fresh. So here sum total of the row is 70 multiply the column total is 42. So 70 multiply column total 42 divided by 200, which is equal to 14.7. So here none value in observed value is 14. We obtained the 14.7. So we have added the 14.7 7 in expected sale frequency table. So the total is 24.5, 30.8 and 40.7 is 70. Okay, the same 70 is expected value, the same expected values is the same at observed